I'm taking another look at power output on the 10 gig transverter after making a minor modification to the input attenuator circuit. That input attenuator normally has a 220 ohm series resistor. It's a pi attenuator with a 56 ohm shunted across the input, the 220 ohm series resistor, and a 100 ohm trimmer to adjust the drive level on the other side. I have swapped out the 220 ohm series resistor element for a 39 ohm, and that has made quite a bit of difference here. I've got the signal generator set up to drive this with 10 dB less power than last time. I still have the trimmer in the transverter turned all the way up for maximum drive level, but I've cut down the drive into the whole system by 10 dB. And when I do that, let me power things up and do my thing with the crazy push-to-talk systems here. So when I do this and then apply drive, I'm getting right about the same reading I had before. So 10 dB less drive, I'm getting the same reading I had before. And I've got a voltmeter on here to monitor the DC voltage out of the monitor output on this 10 gig transverter. It has a monitor output that has a DC voltage proportional to the RF. And they say that at 200 milliwatts rated output, that should be 1.2 volts or more. So at this level, I'm not really seeing 1.2. I'm seeing about 1.08 or so. What I have found is that if I go up a little more on the drive level, I can get more out of it. So if I go up, for example, to there, that's about 4 dB more drive. Then I get about half a dB, 4/10 of a dB more output, which isn't really that much. I do just barely make the 1.2 volts here, so what exactly that says, I don't know, but now I do feel that I can get sufficient drive. When I put this 10 gig transverter up on top of the tower, there's going to be about 4 dB of cable loss between the Anglian driver transverter and the 10 gig transverter. So at this level, even at this output level, which is pretty well saturated, I do have 6 dB to play with. This level is 6 dB less drive than I had before, and it's at saturated output. So this is 6 dB less drive than the maximum output of the 2-meter Anglian transverter. So I only need to buy myself 4 dB, so I should have a couple dB more than I need there now. So I think that's all set there. One thing I will say is this is not very linear. Let me just key it up again. So there's full drive to pretty much saturated output, and if I go down 1 dB, it's just a tiny bit of change. Down 1 more dB, 1 more dB, 1 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 dB. So even here it's not perfectly linear, and now I'm down I'm down 4 dB or so, so 5, 6, and even there it doesn't look that linear. So I don't know, even 4, 5, or 6 dB down from full output, it doesn't look all that linear to me. I don't know that that's a big deal for me. I expect I'll be running mostly CW or digital modes with this and very little SSB, and I don't have any local hams who would be likely to complain about non-linearity and splatter on SSB anyway, so I'm not concerned about it. It's just something I have taken note of. So I think with the modification of changing out that one surface mount resistor in the transverter, I'm all set now on drive levels, so when I put this up on the tower, I think I'll be okay. Whether or not it's making exactly the 200 milliwatts it's supposed to, I don't know. According to my meter, it is. That's a 30 dB attenuator on the output, which, as far as I know, is pretty close to 30 dB. It is when I check it at lower frequencies where I have the equipment to do so. And, you know, I'm getting a reading of a little above -2 on the scale, which, with -5 dBm full scale on here, is actually an actual level of -7. Plus 30 dB would be plus 23 dBm, which is 200 milliwatts. So as far as I can tell with my setup, I am getting the full rated 200 milliwatts out of it. I don't feel I'm in a position to be certain of that, but I think I'm in that ballpark anyway. So there we have it. I think that's all the transmit testing I'm going to do on the 10 gig transverter for the time being, and I'll set up here in a couple of days when it stops raining and see what I can do with receiver testing. I don't have a signal generator that covers this frequency, so I'll have to improvise and use a microwave signal source of some sort and an antenna on this just to make sure everything is receiving correctly. So that's it for today's test.